so we're solving linear inequalities. So last time I solved linear inequalities, what I called by hand or algebraically or symbolically. And so now we're just going to look at how to solve them graphically. Alright, so how to solve them graphically. So again, graphically, this is sort of the concept behind it is they're equal to at where they cross, where they intersect, right? That's what the equal to part is. And so wherever they intersect is where my two equations are equal to. So in this graph here, this part A, where they meet, where they intersect, is when my first equation is equal to my second equation. Alright, that's if they're equal to each other. So that's where we would start our interval. Alright, we'd include that moment. If it's equal to, we'd put a parentheses around that moment if it's not equal to. And so again, this moment, if we're looking here, was 1982. And then we want to know when the function f of x is above m of x, because we're looking for when is f of x greater than m of x. Right? That's what we're looking for in this particular application. And so when is it bigger than, right? A bigger than would mean these values on the red line are bigger than these values on the blue line. And so the red line, the red function, is bigger than the blue function on this part. Right? That's when the red function is bigger than the blue function. And so I go look and see, well, what x values make that true. And so those dot means the function's stopping here, and so it's going down, and so that's what this green line indicates. And so this represents 2017. And so the red line is bigger than the blue line between 1982 and 2017. Right, so that's the answer. We stop at this point and it's a closed point, meaning that point's included, and so 2017 is equal to, but we don't include 1982 because I just want to know when it's greater than it. When is it bigger than it? Well, it's bigger than it at the end here, right? This is obviously bigger than this at this point. Here, they're equal to. We don't want equal to, so I don't include 1982, but 1982 is where we're starting. From 1982 and beyond, so beyond 1982, so it's from 1982 and everything after that up to 2017, the function f of x is greater than the function m of x. All right, so that's my answer. I want everything between 1982 and 2017. And we're going to do another graphical example, and again, I'll use the calculator. Or, again, you'll be using the calculator. So on the calculator, graph these two equations. So graph 1/2 x plus 2 on your calculator, and graph 2x minus 1. Right, I did it by hand here on the paper, but you can use your graphing calculator. So if you want to, again, plug those into your graphing calculator. A standard window should work, although this window is a little zoomed in. It's a 5 by 5 if you want to change it to 5 min and -5, -5 min, +5 max, just so that the picture came out a little nicer. Alright, so the blue line represents the 1/2 x plus 2. The red line represents the 2x minus 1. And I want to know, when is my 1/2 x plus 2, so when is the 1/2 x plus 2 bigger than the 2x minus 1? Right? And so again, this would be the blue line. This is the red line. The point where they intersect, which is the point 2, 3, is where they intersect, which you can find that on your calculator, right? We talked about this in the last section. That's when they're equal to each other, right? Which is my starting point. I don't actually include it, but 3 is going to be a part of my answer because I'm either 3 and bigger or I'm 3 and smaller. And so I look to see, well, I want the blue line to be bigger than the red line. So if I go look here, where is the blue line above the red line? That's what I'm looking for. And so it's this part, right? This is the part where the blue line is above the red line. And so on this side of my function, my blue line is bigger than my red line. I want the blue to be bigger, which means above in the graph. Red line smaller, which is below. Right? That happens when I go from the 2 and everything down in the negative infinity direction, right? Everything from 2 to negative infinity, if If I plug anything between 2 and negative infinity, the blue line is bigger than the red line. And so the answer is I want all x that are less than 2. Less than 2 because it's not equal to 2, right? All x values that are less than 2. If you solved it by hand, you should come out with the same answer. But you can always double check yourself and solve it by hand if you want to. Alright, but that's the answer. I want everything. You could check your answer. If you plug 0 in, that would be true. Right? If you plug 0 in, which is 0 is less than 2, right? 0 lands here. 0 would make this 0 out, leave me with a positive 2. 0 would make this 0 out, leave me with a negative 1. 2 is bigger than negative 1, and so that's the answer. So there's my answer. All x values less than 2, and so the set notation, I want every x such that x is less than 2. The interval notation would be I want everything from negative infinity to 2, not including 2, so we put parentheses. Right? Had it been an equal to, well, you just put equal to, and then brackets. That's how it changes. So had it been an equal to, you would just do that instead. Alright, so that's a graphical example. And we'll do one more graphical example, kind of combining graphical with a numerical table, and we'll do that in a little bit. And then I'll do more examples at the end. Alright, but that's how you solve it graphically. So you graph the function. The point where they intersect is where you start, and it's either going to be bigger than that point or less than that point. So you're either going to shoot off to infinity from the moment where they intersect, or negative infinity. You have to just figure out which one is the answer. Right? Which one do I want to be bigger than the other one? Which one do I want to be smaller than the other one? Bigger than always means above. Smaller always means below. All right, and so there's my graphical. And like I said, I'll do another graphical example later. Actually, I'm going to do a graphical example special case in the next video. And then we'll do more graphical examples later. So there's one example of graphical